guys, welcome back to my channel. In today's video, we're going to be discussing what functions are. So in my last video, we talked about relations and inverses. In this video, it's just expanding on those two ideas. So a function is just a special case of a relation. So this means that all functions are relations, but not all relations are functions. Okay? So the definition of a function is a relation where each element of the domain has a unique element in the range. So in other words, for each input value, there can only be one output value, okay? So the first thing that we want to do is we want to look at these two relations. So I have A and I have the inverse of A. And so if we recall from my last video, or just as a refresher, we got the inverse of A by just swapping the x and y values of the original relation, which is just A. And yeah, so if we can see, we have negative 1, 7, and we turn that into 7, negative 1. So we just swap those x and y values, and we did this for all 5 ordered pairs. Okay, so now what we're going to do is we're going to determine if A and A's inverse, so the inverse of A, are functions or they're just regular relations. So how I usually do this is I look at the domain, or all the x values of the relation. So I have negative 1 right here, 6, 4, 4, and 3. Okay, so what catches my attention is that 4 repeats twice, right? So we need to pay close attention. Now we notice that 4 is associated with the output values 0 and 10, meaning that it does not follow under the rules of a function, right? Because if we recall, each input value, there can only be one output value. And so in this case, 4 has 2 output values, so it does not follow those rules. So we can say this one is not a function, so we'll just put NF for not a function. Okay, so now let's look at the inverse of A. So we have 7, 3, 0, 10, and 12. Okay, so that checks. So now we're going to look at those y values, or our range. So we have negative 1, 6, 4, 4, and 3. So we'll notice that 4 does repeat twice, okay? But we should not be confused that 4 is used as an output value for 2 different input values, right? Because the definition of a function does not actually place any stipulations on the output values, right? Because each input value has a unique output value, so this means that the inverse of A is a function, right? So that's how we kind of determine if it's a function or not when we're given the set of points. All right, so now let's move on to this next example. So right here, we're going to determine if B, the relation of B and C, are functions, and then we're going to take a look at the inverses of those. Right, so let's first look at B. So right here we have 3, 0, 9, 3, 6, and 5. And again, I'll notice that 3 repeats twice as an input value. So if this were a function, we need to be sure that the output values are the same, right? So we have negative 7 and we have 5. So this means that these are actually different, right? They're different. They're not unique to just 3. So this means that this is not a function, again, because our input value has 2 different output values, right? So now that we determined B, let's look at our relation C. So we have, and you'll notice that instead of just numbers, we actually have kind of like names. So we can call these kind of like variables or anything, but we'll just take a look at this. So we're going to treat this the same way, right? We look at the names in this case. So we have Kristen, Stacy, Kate, Colin, and Carson. These do not repeat, right? So now we're going to look at our y values, or our range. And we have 5, 21, 9, 8, and 12. And everything is unique to one input value and one output value. So we're going to call this a function, right? So now let's move on to the inverse of B. So let's look at our y values first. So we have negative 7, 2, negative 10, 5, negative 2, and negative 1. Sorry, this is 2. Right, so we'll notice that everything is pretty much, this is unique because no input value has multiple output values, right? So negative 7 we don't see another negative 7, right? 2, same thing for each one of these values. For 2, negative 10, 5, negative 2, and negative 1, they all have a unique output value. So we can call this a function, right? So now let's move on to the inverse of C, right? So we have 5, 21, 9, 8, and 12, right? So none of these repeat, so we just need to make sure it's a function by looking at our range. We have Kristen, Stacy, Kate, Colin, and Carson, right? And these are all unique, so this is also a function. Right, so now I want you to notice something very, very unique. So if we look at C and its inverse, C is a function and its inverse is a function. So when we see a relation where the relation itself is a function and its inverse is a function, we call this C is a 1-to-1 function, okay? So C is a 1-to-1 function because its inputs are unique to its outputs and its outputs are unique to its inputs, right? So it's 1-to-1. For every input value, there's one unique output value, which makes it a function. And when you're looking at its inverse, each unique output value has a unique input value. So this means that C is a 1-to-1 function. And this, again, this is kind of like a subset of functions, and this is very unique to C. All right, and obviously B is not a 1-to-1 function because B itself is not a function, but its inverse is a function, right? So that's something cool to know. Well, thank you guys for watching this video. Hopefully you look at my other Algebra 2 videos, and make sure to subscribe, and yeah, thank you.